Hey guys, it's Miss Adams, and we're still looking at our Unit 7 test review. And now we're going to look at the characteristics of our quadratic functions from a graph. So, because I like to just go ahead and identify some of my key characteristics, I'm going to look at my vertex first. And looking there, I've got a vertex at -1, 3. And I know my axis of symmetry must pass through my vertex. So it's going to be the x value through that vertex. So that's x equals -1, and that is a vertical line, so make sure to write it as an equation. Then it asks me for my maximum or my minimum value. Because my vertex is a max point, I'm looking at my max y value. So in this case, my maximum value is 3. Now looking at the domain of any quadratic function, it's going to be -infinity to +infinity. But since we have a maximum, that's also our highest y value. So my lowest y value is at -infinity, but my highest y value is at 3. And I'm going to put a bracket around that because that's indicating that that 3 is included as an output for my function. Then we need to look at end behavior. When x goes to -infinity, my y values are approaching -infinity. And since this is a quadratic function, they need a match. So since x approaches +infinity, my y value also approaches -infinity. They're both facing the same way. Now let's go to problem 24. My vertex for problem 24 is at -1, -4, giving me an axis of symmetry through that x value of the vertex at -1. This one is facing up, so we're going to have a minimum value at our y value of -4. This will also affect our range in just a little bit. If I was to look at the range, this would be from -4 all the way to +infinity. It then asks me for my x-intercepts. And in this case, we have two x-intercepts, one at -3, 0, and one at 1, 0. Then looking at the y-intercept, I've got a y-intercept at 0, -3. And last but not least, looking at the end behavior, this is facing upward, so both of my end behaviors are approaching that +infinity. No matter if you go from -infinity or from +infinity on our x values. That leads us to problem 25. So 25 is asking us a few different characteristic questions. First thing it says, what is the domain? And that's going to be from -infinity to +infinity. But before I even answer the range, I like to go ahead and identify where my vertex is. This case, my vertex is at -4, +3. And I know that that y value, that 3, that's my maximum point. So I know my range is going to start as low as -infinity, but it's going to go all the way and include that value of 3. So that's why we have that square bracket there. It's showing me that that 3 is included as an output for my function. Now I'm going to need my axis of symmetry. This is going to help me with my intervals of increase and my intervals of decrease. So I know something is increasing when it's going uphill. So I'm looking at these values of x. So on what values of x does my y value increase, or does my function increase? So that's going to start all the way over at -infinity, which we don't really know what -infinity is. We just know it's going to continue increasing from the left-hand side all the way until we get to our axis of symmetry, which in this case, my axis of symmetry is at x equals -4. So when I write that interval of increase, it's going to be from -infinity to -4. Which means that my interval of decrease has to start at -4. And it's now going to continue on to +infinity. So this is where my function is decreasing. So it's going downhill. It's also asked me to state some transformations that have occurred to the parent function. So if I'm looking at this, first off, I know it's facing downward, so there's been a reflection. Then I'm going to look at my vertex to give me some other characteristics. Looking at that h value of the vertex, I know I've gone left 4 units. And looking at the k value of the vertex, I know I've gone up 3 units. When it says that parent function of x squared, that's just saying that there's been no transformations performed on that function originally. All right, guys, let's go ahead to the next page and look at problem 26. So we're doing some similar ideas here. let's go ahead and identify that vertex in the axis of symmetry. That vertex being at 3, 1, and the axis of symmetry being where x is equal to 3. Our domain is never going to change for these quadratic functions, so it's going to be negative infinity to positive infinity. But our range is going to be affected by our vertex. I know my minimum y value is 1, so I'm going to start at the value of 1, which is included in my function. And both of my ends are approaching positive infinity, so my range is going to go from that 1 value to positive infinity. Next, we're going to look at our interval of increase. So this is where our function is going uphill. And that actually starts at my axis of symmetry, so at that value of x, where x is 3. And that's going to continue until x is positive infinity. So I'm breaking my domain in half with my axis of symmetry. That means that my interval of decrease is going to be all the way on the left-hand side. So starting where x is negative infinity and going until x is at positive 3. It then asks me for my x-intercepts, but notice that the vertex is above the x-axis, so we're not going to have any. There are going to be no x-intercepts. Note, don't put 0, 0 for this. If you put 0, 0, that will not be the correct answer. That is actually a point on the coordinate plane. So just go ahead and put none. You can put not applicable. You can put NA. Don't leave it blank. We've got to know that you understand that there is no x-intercept. You could put the word no. Just make sure that you are stating that an x-intercept does not exist for this function, or you could put D and E. Now we're going to state those transformations. The only transformations that we really had depend on our vertex. So looking at the vertex, I know that we've gone to the right by 3 units. And also looking at that vertex, I know that I have gone up 1 unit. And guys, that leads us to the last portion of this review. So in the next video, we're gonna look at matching these equations and how to understand, like, from each form of quadratic functions where we can match these equations.